This is number 7 from section 4.4 homework. This is a tricky problem, okay? City A and City B are 175 miles apart. A car leaves City A traveling towards City B, and another leaves City B at the same time, that's going to be important, traveling towards City A. The car leaving City A averages 15 miles per hour faster than the other, and they meet after 1 hour and 24 minutes. What are the rates of the cars? Okay, so what I notice on my first read through is I have City A and I have City B, and I have two cars that leave at the same time and travel toward each other. So this car is going here, this car is going here. I know that the total distance between these two cities is 175 miles. Okay. I know that the H car is faster than the other, and they meet after 1 hour and 24 minutes. Okay, so another thing that I notice is that this is in miles per hour, and right here I have a combination of hours and minutes. I need to match my units. So before I even start filling out the rest of my picture, what I'm going to do is I'm going to take this. It is easier to convert minutes into hours than it is to turn miles per hour into miles per minute. Okay? So if I have 1 hour and 24 minutes, 1 hour, okay, I'm going to convert this 24 minutes. That's 24 minutes out of 60 minutes, okay? Which means if I take 24 and I divide it by 60, what I get is 0.4. Or if I take this fraction and I reduce it, I would get 2/5. So instead of using 1 hour and 24 minutes for your time is going to equal, you can use either 1.4 hours or you can use 1 and 2/5 hours. Either one of these will work. I'm going to use the decimal version. Okay? So let's come back to our picture. If I can find a way of talking about how far this is and how far this is, then if I add those two distances together, I should get 175. So that's going to be one of my goals. Okay? Then I also have to take into account that one is 15 faster than the other. Let's start off with the distances. Okay? We're looking for their two rates. Okay? So let's just call this car A and car B. So the car that's leaving from City A. Let's say this is going X miles per hour, and that car B is going Y miles per hour. Okay? The time car A travels is 1.4, and the time car B travels is also 1.4 hours. So the distance traveled this is going to be rate times time. So this is 1.4x, and this will be 1.4y. So this distance right here is 1.4x. This distance right here is 1.4y. Okay, so the total distance traveled, if I add these two things together, I get 175. That's going to be my first equation. 1.4x plus 1.4y is going to equal 175. Now my second equation, I need to use the A car is faster than the other car. That means if I take A and I subtract the B speeds, the speed of A, the speed of B, I should get 15 because there's 15 between them. Car A was the faster car, so X minus Y is going to give me the 15 mile per hour difference between the two cars. Now this is the system I need to solve. It's going to be fairly easy for us to get rid of y. I just need to multiply the entire equation by a 1.4. My first equation stays the same. My second equation is 1.4x minus 1.4y is equal to 1.4 times 15, is 21. Okay, now let's add these together. The y's cancel out. 1.4 plus 1.4 is going to be 2.8x equals 175 plus 21 is 196. Now divide both sides by 2.8. And you get x is equal to 70. So I found my x. What is x? X is the speed of car A. I'm asked to find the rates of both cars, so I'm half done. I've done the hardest part. Now I just need to take this value and to plug it into one of these two to find y. Well, it definitely looks easier to plug into here for me. So this will be 70 minus y is equal to 15. I need to subtract 70 from both sides. That gives me negative y is equal to negative 55. So change the signs on both sides. Y is equal to 55. So this faster car is going 70 miles per hour. And the slower car is going 55 miles per hour.